Good morning. Today is Tuesday, April 21st, and we are back again to discuss our exploration of space Jacob's Ladder activity. As I said yesterday when we read through the article, we are going to do it just bit by bit, a few questions a day, and then we will be on our way. So our goal is to finish this one by the end of this week. So the first thing we're going to do is we are going to go back through and reread our story before we start answering some of our questions. So just remember those things that we talked about yesterday, those things that you made notes of to help you as you read. And here we go. The exploration of space gives scientists the opportunity to learn about the sun, stars, and planets. Some space exploration involves scientists called astronauts traveling into space. Astronauts use spacecraft such as space shuttles to travel beyond the Earth's atmosphere into outer space, which begins about 60 miles above sea level. While in outer space, astronauts explore their surroundings with various tools such as safety tethering systems to keep their spacesuits attached to the spacecraft or small tethers that attach their tools to their spacesuits. Astronauts might also wear a safer or simplified aid for EVA rescue. EVA stands for extravehicular activity, another term for spacewalk. A safer is like a backpack. Use a small jet thruster to allow an astronaut to move in space. Other space exploration does not require astronauts, but instead uses spacecraft with robots or other mechanical devices such as satellites to gather information. In order for spacecraft, manned or unmanned, to travel into outer space, they must first overcome the pull of Earth's gravity. The heavier an object, the more power is required to break the Earth's gravitational pull. As you can imagine, it takes tremendous amount of power to launch a space shuttle. These large spacecraft require booster rockets full of fuel to launch them. The boosters burn the fuel that gives off gas bursts that pushes the spacecraft into the air. The spacecraft eventually reaches a height where the Earth's gravitational pull no longer affects it. Once it passes this point, the shuttle only needs to fire rockets to increase its speed or to change directions. When a spacecraft is ready to return to Earth, it must first slow down. Once it re-enters the atmosphere, it slows down considerably and begins falling towards Earth. The spacecraft deploys or puts into action parachutes to further slow down its descent. Spacecraft, like space shuttles, land on runways just like airplanes. Some of the earlier spacecraft splashed down in the ocean where astronauts were picked up by boats. On October 4th, 1957, the Soviet Union launched Sputnik, a satellite that orbited Earth, and space exploration officially began. Years later, on April 12, 1961, Yuri A. Gagarin, a Soviet cosmonaut, became the first person to travel to space. In December 1968, the U.S. took their first trip to the moon in the spacecraft Apollo 8, orbiting the moon 10 times before returning to Earth. Less than a year later, American astronaut Neil Armstrong became the first person to walk on the moon on July 20th, 1969. As Armstrong placed the American flag on the moon, he said, "That's one small step for man, one giant leap for mankind." Since the historic landing on the moon, astronauts have continued to explore space by traveling there and by studying data collected by satellites and other unmanned spacecraft. Through space exploration, astronauts and scientists have learned to continue to learn much about the universe and beyond Earth. There you go, boys and girls. Now, your two questions for today are going to be on slides 8 and 9. Your first one is a sequencing question where you're going to create a timeline of the space events. So this is one of our bottom of the ladder questions. When we do this Jacob's Ladder, we always start at the bottom. Timeline of space exploration. So if you go back in your story, there are specific events that were given dates and times, and you're going to make a timeline. And if you can organize that horizontally, then great. If not, you might, when you click in here, might want to click on one of the tools up here and make a bulleted or numbered list. That's fine as well. On this part, you do not have to answer in complete sentences. You can answer just with the dates and then what happened. You need to give me enough information so that I know exactly what you're talking about. On slide 9 is a little bit different. You're going to work in this box over here. And of course, you can adjust the size of it as needed. You're looking at cause and effect. And your question is, what is the effect of Earth's gravitational pull on spacecraft during launch? During reentry? Support your answer with evidence from the text. So you're looking at two things here. And to get full credit, you have to answer both parts of the question. What is the effect of Earth's gravitational pull on spacecraft during launch? And then during re-entry, and you must use information from your text to support your answer. This question must be answered in complete sentences. So for both of these, you're going to need to go back into your text over here to give good, solid answers for these questions. Make sure when you finish that you submit it to me in Google Classroom. Bye, guys. Love you.